Welcome to the e-learning platform by Science Park. So today we are going to learn about sound. This is the part 1 of the session from 7th standard and it covers chapter number 18 from SSC board. So let us see what we are going to learn today. So in the beginning we'll just revise about periodic motion. Then we'll see what do we mean by oscillations, oscillator and oscillatory motion. Then we'll learn about a few terms related to oscillations, and simultaneously we will also see the relation between them, specifically between time period and length, time period and amplitude. And in the end we'll understand what are the characteristics of sound. So let us begin with the revision of periodic motion. So friends, as you know what is periodic motion, just I will tell you. So here we have an orbit and a sphere which will revolve in the orbit. So the characteristics of periodic motion are, it is a repetitive motion, so it repeats itself and it repeats with fixed time. So that means the time required for one repetition or one revolution is always the same for all the revolutions. The time doesn't change. So such motion is called as periodic motion. Right. So now we have a rigid ceiling to which we have attached a string and a bob, which is also called as a pendulum. Friends, you might have seen such type of pendulums in wall clocks, in hanging wall clocks, right? So it moves to and fro. So we are going to understand about that, the motion of the pendulum. So like I said, the motion is to and fro. It also repeats itself and the time is also the same, but in this case, it is to and fro. It repeats on the same path. It goes and it comes back. So such motion is called as oscillatory motion, which comes and it goes back, right? To and fro motion. And one such to and fro motion is called as oscillation. So when the bob is on the leftmost side, when you release it, it goes to the rightmost side and it again comes back to the the position, the leftmost position. So one such whole path is called as an oscillation. And this pendulum is nothing but an oscillator which oscillates, right? So there are different examples of oscillators. You can also have a spring and a weight attached to it, and if you suspend it, it will also act as an oscillator. Right. So this is the total path which is covered by the pendulum, right? So this is called as the amplitude of the oscillation. So this is the first term which you are going to learn about oscillation, which is the amplitude. How far it goes from the mean position is called as amplitude. So now to understand the remaining two terms related to oscillation, we have here a wheel and a stick, and this will rotate, and we will count the number of rotations and the time required for it. So for one rotation it takes 2 seconds, for 2 4, and for 3 rotations it took 6 seconds to complete the rotations. So this time which I have written here in seconds, 2, 4 and 6, is nothing but the time period. So time period of this motion was 2 seconds. Time period, we can define it as a time required for one complete rotation or revolution, right? Now we have another term which is called as frequency. Now frequency, as you can see, is defined as the number of cycles or number of rotations per unit time. So if we divide number of rotations by the time in seconds, we will get the frequency. So in this case, we have 3 rotations divided by 6 seconds, which gives us 0.5. And the unit of frequency is hertz. Okay, hertz is the name of a scientist, right? So this was in the case of a wheel. Now let us understand time and frequency in case of a pendulum. So here I have a pendulum and I'll measure the oscillations and its time period. So let us begin. So it has completed 1 oscillation, it took 4 seconds. For 2 oscillations it took 8 seconds. And finally for 3 oscillations completely it took 12 seconds. So the time period is 4 seconds and frequency is 3 divided by 12, which is 0.25 or 0.25 hertz. So this is the frequency of the given pendulum. Now we have another pendulum, and now we will change the length of the string or length of the pendulum itself to see how it affects the time period, or does it does or does not it affects the time period. So here I have a pendulum. I'll start its oscillations and measure the time period. So for 1 oscillation 4 seconds, for 2 oscillations 8 seconds, and for 3 oscillations it took 12 seconds, right? Now just remember that for 1 oscillation it took 4 seconds. Now I'll change the length of the pendulum. I'll reduce the length. I'll decrease the length. Now see what happens to the time period. So I've started the oscillations. For 1 oscillation it has taken 2 seconds. For 2 oscillations 4 seconds. And for 3 oscillations it took 6 seconds. So the time period now has been changed to 2 seconds. So my dear friend, what can you deduce from this? Yes, so I have the length of the pendulum and the time period, and if I decrease the length, the time period also decreases, right? So time period depends on length. If we increase the length, the time period will increase, right? So if you have observed the pendulums which are mounted in wall clocks, and if you try to measure the time period of that pendulum, it is exactly 1 second. So the length of the pendulum is adjusted such that the time period will be 1 second, right? Now I have a pendulum, and now I will check whether by changing the amplitude does it make any difference to the time period. Let us see that. So the amplitude is shown in red line. For 1 oscillation it took 4 seconds, and similarly for 2 it takes 8 seconds, and for 3 oscillations it takes 12 seconds, right? Now I'll change the amplitude, rather I'll increase the amplitude. So the amplitude is increased and we have started the oscillations. So again for 1 oscillation it took 4 seconds. For 2 oscillations it took 8 seconds, and for 3 oscillations it took 12 seconds. So my dear friends, from this we come to know that by changing the amplitude, time period doesn't change, right? So the change in amplitude have no difference in the time period, right? So now we will understand the different characteristics of sound. So here we have got a musical instrument, a keyboard, which is connected to the amplifier, and this amplifier, the output of this amplifier is connected to this speaker, and we have taken an additional output on this instrument, which is also called as cathode ray oscilloscope. You can see a screen here, right? Now we will concentrate on this screen. So I'll press a button here and you have to observe what you see on this screen. You see a beautiful wave, and you are also able to hear some voice. Now I'll increase the volume. Let's see what happens here. You see the amplitude is increasing. Now I decrease the volume. The amplitude also decreased. So friends, this is the first characteristic called as loudness, which depends on the amplitude of the wave. Now we will see the second characteristic, which is pitch. So we'll again concentrate on this screen here. So now I'll play a note. And I'll play a different note. So you see the pattern of the wave has changed. So this time it looks they are much close to each other. And also you can observe the difference in the sound. So this is the second characteristic called as pitch, which depends on the frequency of the wave. Now I have selected a particular instrument on this keyboard. Now I'll select another instrument. Now we will focus on this screen to understand the third characteristic, which is quality. The sound you were hearing before was very soothing. Now this sound is particularly not so soothing, and you can also see it from the wave pattern. So the sound which you heard before was of good quality. So this is the third characteristic, which is called as quality of the sound. Right. So now that we have seen the characteristics of sound, we will understand it in a much better way now. We'll revise it again. So here we have a cathode ray oscilloscope. So when we switch it on, we see a wave, and right now here we see in the display it is written as 2V, that is 2 volts. So this is the amplitude of the signal. Now if we change the amplitude of the signal, you can see the amplitude has changed, and if you observe while the clip, was playing on, the intensity of the sound also increased. So the loudness also increased. So again, if we change the amplitude to 6 volts, the sound will be much louder. So loudness does depends on amplitude. If amplitude increases, more loud the sound will be. Right. So here now we will select frequency. So here we have a particular frequency, let's say 100 Hertz. If we change the frequency, you will see in the same length we have got 4 different waves. Earlier we have 2 waves. So the frequency is doubled. Now it is 200 Hertz. The pitch of the sound will increase. Now to understand pitch, you know the 7 different musical notes. Sa, re, ga, ma, pa, dha, ni. Right, so each note has a different frequency. So the sa has less frequency than other notes, and ni has the highest frequency among these 7. And now you can imagine the difference in the pitch of the sound and how it is related to frequency. Now if I again decrease it to 100 Hertz, the pitch will decrease. And if I decrease it furthermore, let's say to 50 Hertz, again the pitch will be much less. Right. So pitch is directly dependent on the frequency of the wave. So if frequency increases, the pitch also increases. Now we have seen a very beautiful sine wave till now. Now we can see a very, it's not a particular type of wave we can see. Just the pattern is repeating. So the quality of this sound, if you hear, is not so good. But the quality of the sound which you heard from the sine wave was very good. So from this we can also deduce what is the quality of the sound. Right. So let's summarize the session. So in the beginning, we just revised about the periodic motion. Then we have seen what are oscillations, what is an oscillator, and what is oscillatory motion with the help of a pendulum. Then we've seen three different terms related to oscillations, like amplitude, time period, and frequency. Then we have seen the relation between time period and length. And we have also seen that if we change the length, the time period changes. And we have also seen that if we change the amplitude, the time period remains the same. And in the end, we have seen three different characteristics such as loudness, which is dependent on amplitude. Then we have seen pitch, which depends on frequency, and the third characteristic, that is quality. So here are few questions. Kindly note these questions in your notebook and write the answers to them. Thank you.